go through the three differentiation first. All of you look up. d dx sine x will give you cosine x. d dx cosine x will give you negative sine x. Okay? And d dx tangent x will give you cosecant square x. Is this correct? Yes or no? Whose is this? The one give me also can, doesn't matter. I am very good with papers. Okay? Now, are we okay with these three? Then I told you that because for trigonometry, right, when dy dx is 0, you're actually solving three equations. So it's some sort of a problem because some people forgot. Okay? Now, I'm going to go through example 4 as promised yesterday. Yeah? So I'm going to go through that one again. Then I'm going to go through EX today. Okay? So that tomorrow during HPL, you just do 15 and 1 and 15.2 homework. Then you don't have to trouble. You know why I don't want to teach online? Because you cannot see me, it's not so comprehensive. You understand? I don't like it at all. You understand? Certain things must be done physically. Huh? Now, let's take a look at example 4. Y is sine x minus 2 cosine x. Find the coordinates of the stationary points of the curve for this. Now, of course, yesterday we have already done it. We differentiate this, right? We will get cosine x plus 2 sine x, right? Okay? Then to find stationary points, I will have to equate dy dx to 0. Now, I told you yesterday, it's actually a revision from long time ago. I mean, from last year. That if you have a 0 and you have sine, cosine, you can actually divide by cosine x. You change it to tangent. Okay? And I also said that if this is a number, you have to use R formula. And there's a very easy way to use R formula. If you have seen my previous video for last few years, you will see that the R formula is actually very simple. Okay? You just compare with the compound angle formula and just plug it in, that's it. Okay? But when I do revision for MS, I'll tell you again. Okay? Alright, so I'll have 1 plus 2 tangent x equals to 2, equals to 0, sorry. So, tangent x equals to negative half, right? Then I revise something called reference angle or basic angle. For me, I always call it the basic angle. Okay? Then you found out for me that it's 0.4636, right? 4. Oh, the textbook round off. We truncate that. Okay? Now, then we also know this CAST. Because tangent is negative, it will fall on this and this quadrant, right? So, in order to be here, I will have x equals to pi minus this guy here, and also 2 pi minus. So, you will get 2.6. What? Yesterday you tell me 5 truncate. 6 what? 6, 7, 8, 9. 6, 7, 7, 9. Okay, this one? 5.8195. Okay, into 3, it should be like that, right? Okay, to 316, it should be like that, right? But the question says to find the coordinates. So, when x is 2.6779, y will be, you got to plug into this. Okay? You got to plug into this. Alright? Can? Okay, can you plug into this and tell me what is this answer? All of you plug into the box. With radians, with radians. So what should it be? Yeah, what should it be? 2.2360. How about when x is 5.8195? What is my y? Negative of this, right? 2 2.2360, right? So actually my two stationary points are 2.68 and 2.24, 5.82 and 2.24 negative. Am I right to say that? These are my two stationary points. Okay, class? Can or cannot? Okay, now actually, if they never say use first derivative, second derivative is faster. Can you see, just differentiate this again. This one become negative sine x, then plus 2 cosine x. So plug in, you can get the maximum or minimum point straight away. Correct? But because they say use first derivative, so we have to follow now. We're very obedient, right? So we have to follow. Okay. Now, at 2.68, 2.24, I will do slightly less will be about 2.6, right? Slightly more will be about what? 2.7. Do you all see what I'm talking about? Okay. So you will get this one, dy dx will be 0. This one is actually positive. This is actually negative. So positive 0. So this is actually a maximum point. Can you see what I'm talking about? It's actually a maximum point. Then we go for this 5.82. So it's actually slightly less is 5.8. Slightly more is what? Just about 5.9. Okay? Correct? Then you will get a negative 0 positive. So negative 8. Salah. Negative 0 positive. So you will get a minimum point. Is that clear? Yes or no? Okay, now because this is use first derivative, we have to do this. But I want to show you second derivative, you will also get the same answer. Okay? Now, can we differentiate this again? d2y dx squared, what do I get? Negative sine x plus 2 cosine x, right? Okay, I want you to plug in 2.68 into this. Can you plug in 2.68? Everybody? Plug in 2.68. Is the answer negative? So this is less than 0, right? Okay, can you plug in 5.82? Plug in here. It should be a positive value. So that's why it is a minimum point. Do you understand what I'm talking about now? Okay, for me, right, I think the second derivative is faster. I don't have to plug in 2 times. You get what I'm talking about? So are you clear so far for the trigo? Yes or no? Okay, good. Next, we are going on to EX first. Before I move on to the trigo. Trigo homework, what I mean is, okay. So, exercise 15.1, I will assign it later. Okay, can we move on to 15.2, derivative of exponential function. Now, I will write the differentiation here first. I told you this is the best thing on earth, right? Can you remember I said this is the best thing on earth yesterday? Okay, but because it's the best thing on earth, we have to do more things because the textbook give you a not so good kind of formula. So I am going to repeat that formula, which I'm going to give you now. Okay. d over dx EFX. When you differentiate this, it's just you write out the original, then you times the differential. Right? Remember yesterday I gave you this. So this is the first one. This is the second one. Okay? Alright. Now, so let me go through the examples now. Now, I just want to ask you, are you okay so far? Are you okay so far? I know it's a lot of things, but can't be helped. We still got many chapters to go. Ryan, are you dreaming of EX? If you are not, you better wake up, okay? in your dream, I must be there. Then I must be talking about EX. You cannot guarantee me that you cannot sleep. Huh? Okay, now next. Okay, what nonsense? Like that, right? So I will do dy dx. And you see I have to use product rule. I fix this. I differentiate this. Very good line, still the same. Plus, I fix this. I differentiate the front, become what? 2x. So it's actually x squared ex plus 2x ex. Now, some people will say, Joe, can I leave it like that? Actually can, but can you see there's a common factor of x ex? That's it now. So what do I get? X plus what? 2. This will be the simplest. Okay? But if you leave it like that, it's also okay one. Nobody say must go and factorize. Do you understand what I'm talking about? It's the product rule that I'm more interested in. Okay? Now, next one. When it comes to this, everybody knows that you must use quotient rule, right? Quotient rule means what? Tell me again. Square the bottom. Fix the bottom. Differentiate the top. Very happy, right? It's the same, huh? Minus fix the top, right? Differentiate the bottom. Oh, very happy. This one, right? Okay, so we get just ex, x plus 1 minus 1 over x plus 1 square. I take out common factor ex, x plus 1 minus 1. So, what's this answer? 1 minus 1 is 0, right? So, I will get this as the answer. Is everyone clear? Is everyone clear with what I'm saying? Yeah? Okay. Last one, part C. Okay, what do we get? dy dx. Before class, tell me what do I do first? Take down what? Take down what? 3 power 3 ex plus 2, that's power 2, right? Then I must differentiate the inside. So it's still what? Ex. Very good. So this is 3ex, ex plus 2 squared. That's all. Can you see this is a very, very straightforward one? Everybody clear now? Okay. So once you get ex, it's actually a gift from heaven now. Okay. Now, can I move on to 2 more examples before I assign you the work? Everybody okay? Alright. Now let's take a look at the next example. Example 6. Okay. Now, some people will think that this is actually product rule. Am I right to say that? 3 times this one. Correct? You can think of it this way, but all of you listen first. You fix this, right? You differentiate this, right? Now you look at this one. I must have e 3x minus 1. Then when I differentiate, I times 3, right? Because when I differentiate this one, I left 3, right? Correct. Then plus fix this one, differentiate this one, right? You differentiate 3, what do you get? When you differentiate 3, what do you get? 0, so there's something like that. Don't have already. Actually, when there's a coefficient, you just leave it there and just differentiate. That's it. You don't need to have product one. Okay, so this will become 9e 3x minus 1. That will be our answer. Everybody clear now? Everybody clear now? Okay, next one. Part B. I'm supposed to find the derivative, that means find the differentiation. Fix what? X cubed. I differentiate this one, right? This one must be careful. Oh, look up. E mind writing. E what? 1 minus x, right? But when I differentiate the top, what do I get? Do you see I get negative 1? Must be careful. Okay? Plus, I fix this, I differentiate x cubed, come up. 3x squared, right? Agree, class? Yeah? So, I will have negative x cubed e 1 minus x plus 3x squared e 1 minus x. You say, Joe, I want to take out e 1 minus x, and I also want to take out x. Also can. Okay? So if I take this out, I'm left with what? Negative x squared plus 3x. Actually, I can take out x squared, right? Maximum, I can take out x squared. So this is negative x plus 3. Again, I didn't completely factorize just now. Everybody okay? Everybody okay? Alright now? So the answer is 3 minus x, x squared, e 1 minus x. Everybody okay? Now, you will ask me, Joe, if I leave it here, is it fine? Yes, it's fine. Unless they say show that it reduced to this. Then you have to show. Everybody okay with what I'm saying? Can or cannot? Okay so far? Okay, good. Next one, part C. Once people see this, like, straight away they concuss, cannot do. Okay. G theta. Okay. G theta is E theta over 2. Can see it? Square root is half now. So it's theta over 2, agree? Now, do you agree theta over 2 is actually half theta? Yeah? Okay. So, G prime theta will be this one, right? That means you are differentiating with respect to theta. So, when you differentiate this, I'm left with half, right? So, it's just half E theta over 2. Everybody okay? You ask me, must I put like the textbook, you know, where they put the square root? No need. You just put theta over 2, I'll understand. Everybody okay? Can you see this one is very useful? Rather than the you don't know what nonsense they. It's useful, but. Okay? Now, next one. Part D. This one is not that simple. Because I want to use quotient, am I right? Okay. Can you tell me I square the bottom, right? If you cannot square, please write first. Like this. Okay? Fix the bottom. Differentiate the top, become 3t squared. Minus, fix the top. Differentiate the bottom. 3 remains, right? Talking to you. Then E t square remain, right? I must differentiate this, become what? If I differentiate this, what does it become? 2t, right? Okay? Can see or not? Can you see that? Okay? So, what do I get here? This will become, no, you must be careful. This t square is on top, this one is below 1. Not everything, don't know what is it already. Okay? So this one become 9t square e t square, right? Correct now? Then, okay, let's go talk about. Let's put this t cubed minus 1 behind first. What does this whole thing give you? 6 what? 6t e t square. Agree? Over what? This is what I'm interested in. Over what? 9, right? When I have e t times this one, right? Remember your A, M, N is these two multiplied together. So what is 2 times this? Correct? I'm talking to you. Are you clear with what I'm saying? Then you will say, Joe, how come I never get the one that is in the textbook, right? Correct? Okay, don't worry. We're going to simplify this, okay? Simplify this. Now, what do you think is a common factor for these two on top? 3, okay? 3 what? 3t et squared, right? Okay, on top, left one. 3t, right, for the first one. How about the behind? Left minus what? 2. Correct now? Am I right? Yes or no? Yes, huh? Okay. Then over correct class? Now I'm going to do here very easy first. Don't write down, just listen. This is minus 2t cubed plus 2, okay? Alright? Am I right? Okay, then over 9e2t squared. Okay? Now, what is the meaning of 2e to the power of 2t squared? But some people will be confused with that as well. Do you agree that this one times this one, then you get a 2t squared? Because when e times e, you add up the power, right? What's t squared plus t squared? 2t squared. Can see or not? A lot of people are confused with this, you know. You understand? I'm writing this because I want to cancel off. You get what I'm talking about? Let's say you have ex times ex. What does it give you? E power 2x, right? X plus x, right? Okay? Alright, now I'm going to do the cancellation now. What goes off now? This is 3, right? Alright. T, is there a t below? There's no t below. So et squared goes off. Correct? So the final answer will become 3t minus 2t cubed plus 2. You have a t on top, then 3e t squared. How come I like made a mistake like that? How come I, oh yeah, correct, it's t over this. Yeah. Everybody okay? Everybody okay? Yeah, huh? Okay. Now, next two parts. Part E and part F. And part F. I think the most evil one is part F. You know why I say it's evil? The power is a sign, you know. Can you see what I'm talking about here? Okay, all of you look up now. dy dx. I teach you, this is how I do it. Can you see this is ex, e power something. So I will write the e power something first. Okay, then I differentiate the power to become 2x, so that's all. Nothing. This is just a one-liner. Can you see? Can you see? Okay? It's the next one that I'm worried about. N prime t. Okay, see, this is also power. But this is worse than that one. Okay? So I will have, am I right? I write down the original one. Okay? Now then I'm going to differentiate the top right. Sine when I differentiate become what? Cosine. Don't forget it's t squared. Cosine t squared. Then I must differentiate the inside, right? What is t squared when you differentiate? 2t, right? So can I just write this at the back, no space? 2t then. Correct now? So if I write it nicely, it will be 2t cosine t squared. Am I right? Okay, now don't forget now, when you differentiate sine, cosine, tangent, you must first of all differentiate this thing first. Then it remains. Then after that, differentiate the inside. Everybody clear with what I am saying? Yes or no? Okay, I give you another sine, cosine, tangent one. Look at this one. How would you differentiate this? All of you look up. First, you differentiate the sine first, right? Okay, 4 first. I don't want this, I want this. What do you mean by sine cube? That means sine whole thing cube, right? Okay, okay. Oh, look up, I'm going to differentiate this. Hello. 3 sine square 2x plus 1. Okay. Then you must still differentiate sine of this one. Correct. To become cosine 2x plus 1, right? Then you must have a 2. Correct. Now I'm not going to simplify. Now some people will be confused. How come I do like that, right? Let me just show you. This one actually means agree. I told you yesterday. So when I do dy dx, it's 3 square first, right? Then I differentiate the inside, right? Correct. Hey, talking to you. When I differentiate the inside, become cosine 2x plus 1. Correct? Then I must differentiate the inside again. So it's what? 2. Now, can you see this one comes to this? Everybody okay? Now, can you tell me what is it that you might most likely forget? You remember the 2, no? You will forget this one. Because you thought back down, decrease, okay already. You forget that you must differentiate the sign. Do you know what I'm talking about here? Yes or no? So usually when it's like that, right, I will not write like that. I will write it somewhere, it's like that, so that I know it's outside. Then I decrease. Then I do the inside. Inside I must do this first, then I do the inside of the inside. You understand what I'm talking about? It's like you peel onion like that. You must peel outer, inner, inner. You cannot anyhow peel. Then the onion will be rotten. Do you get what I'm talking about here? Can you see this is actually exactly the same? But the thing is that if I were to look at it like that, some people might just miss it out. Everybody clear with what I'm saying? Okay? Alright, good. Now, so I have already done until F already. I'm going on to example 7. Okay? Example 7. I must warn the person, today's video might not go out on time because I'm washing off Tatoxing. I have an appointment at 2 o'clock at Tatoxing. So I'm washing off. Okay, so I try to upload, but if I cannot do it on time, then tomorrow morning I come push straight away, I will upload. So you just wait. Okay, when it uploads, you just take about half an hour, that's it finish. Okay, I come to school very early one. About 7 I come already. So by the time I upload, you have woken up again. Tomorrow you're going to sleep until 12 o'clock. Yeah, okay, don't ask me. Very sad. Okay? How dare you sleep at 12 o'clock when I have to be at school at like about 7, you know? So envious. I also want, but cannot. So sad. It's the life of the old woman. Okay. Example 7. Now class, I'm trying to make it as clear as possible and try to revise it on the way, can you see it? Because if not, you'll forget, Okay, now let's take a look. Example 7, application. The equation of a curve is this guy here. Find the expressions for dy, dx, and d2y, dx squared. This is a gift from heaven, this type of question. Straightforward. Dy, dx, all of you look up, don't copy, I'll leave this on top. Fix this, okay. See that, not rubbish. I like to fix the first one first so I don't get confused. I differentiate this. Same thing, right? But must times -1, because must differentiate the top. Okay? Plus, fix this, then what? 2x, right? Okay? So, I will actually get a negative x squared e minus x plus 2x e minus x, right? Now, some people say, can I leave it like that? But if you leave it like that now, when you differentiate later, it's very confusing. Because this is a product, this is also a product. I would like to do a factorization. So, I can take out e minus x, right? I'll tell you why I take out e minus x, okay? So, this one I'll be left with what? 2x, right? I want to put the plus in front. Then after that, minus what? X squared, right? Can you see what I'm talking about? Why did I put it in this manner? It's because later on, when I differentiate the d2y dx squared is easier. Do you understand what I mean by easier? Okay? Alright, now, let me double check my answer first. Yes, correct. Okay, everybody okay here? Okay? No, because if you look at the textbook, right? All of you look at the textbook. Can you see after they factorize out, they still use back the original one for what? You get what I'm talking about? I just feel that it makes no sense. Okay? Now, next. d2y dx squared. Okay, all of you look up. This is where it's getting confusing. Okay? First, you fix this guy, right? You fix this guy. So, e minus x. Differentiate this one become what? 2 minus 2x, right? Plus, fix this guy, right? 2x minus x squared. Differentiate this guy. Differentiate this guy is actually e minus x times -1. Correct, not class? Okay, so what do I get here? I will get okay, now I will get a e minus x. Agree, class? The first bracket will give me this one. The second bracket will give me, correct? Yes or no, class? Okay, so I will have to expand out 2 minus 2x minus 2x plus x squared, right? Okay. 2 minus 4x plus x squared. Can not? Like that easier, right? Can you see what I'm talking about here? Like that easier, okay? Now, then you look at part 2. This is important. Determine the nature of each stationary point of the curve. Now, the fact that they ask you for d2y dx squared means this one you use second derivative test. Don't go and do first derivative again, okay? How do we get stationary point? This guy must be 0, right? Okay, talking to for all three, okay? Now, I'm going to show you something here. dy dx is 0 means, correct? This is the differentiation, the first derivative, okay? Which means I will get this, right? Now, e minus x will never be 0. It's always positive. Do you agree? E to the power of anything will never be 0. Even if it's negative, it's still a value. Okay, so this guy is actually rejected. Some people will take long, then after that you see that it's error lah. Also can lah. No waste your time. Okay. Now then this one become x 2 minus x equals to 0. X equals to 0 or x equals to 2, right? I'll have 2 points here. X equals to 0 and x equals to 2. Everybody clear? Everybody clear? Okay, huh? Now, I'm not done yet. Huh? This is a terrible one. Huh? Okay. When x is 0, I plug in here, y is 0. Everybody okay? Can you see it? So, my first stationary point is actually 0, 0, right? Okay. How about when x is 2, what is my y? When x is 2, my y will be 2 squared e minus 2, right? Which means this is 4 over e squared, right? Now, in A maths, we can leave it in terms of e, because e is an exact number. You understand what I'm talking about? No need to evaluate. Then you say, what if I want to evaluate? Can I? Then give it to 360 figure, the final answer. Okay? So the second point is actually 2, 4 over e squared, right? These two are my stationary points. I just want to ask you, are you clear? Yes or no? Okay. Then must test. At 0, 0, d2y dx squared will be, when this is 0, this is 1. Can you see it now? Wow. E minus 0, 2, actually it's just 2 lor. Because minus 0 is still 0, right? So it's just 2. So this is positive, right? So this is what point? Positive is a minimum point, right? Is everyone clear? Okay, then what if when your x is 2, e minus 2, I have 2 minus 8 plus 4. E minus 2 into negative 2, right? Now you know e to any power is positive, right? Correct? Do you agree? It's always positive. Times a negative, this will be less than 0, right? Or if not, you go and key in your calculator, you'll get less than 0. If it is less than 0, that means this is a what? Maximum point. Are we okay so far? Are we okay so far? Now, I just want to caution you one thing. It is not difficult. But the thing is that when you manipulate and when you simplify, you will get into trouble because you are not careful. Do you understand what I'm talking about here? Yes or no? 4 or 3? Okay. Alright. I have 5 more minutes. I have to give you your homework. There's no need to fill out the file because there's no file. The file is with me. And I will go and pressurize them to give me back the file when school is open. If they don't check, then I'm going to blast them off. Because my class will function without a graph. I mean without a file, not without a graph. Without a graph can function anytime. Okay, now I want to do on 2 steps separately. Okay, I'm going to give you the questions now on the board. Now, if the question didn't let the function be y equals 2, can you please let it be y equals 2? Then it will be y dx is faster. Okay, 15.1. but I only gave part of some questions. Can you see some of them is actually a one-liner? You get what I'm talking about? Okay, don't worry, I'll give you discount later, half price, okay? Don't scared. I'm not very kind of I'm still a bit, I got some compassion, little bit of compassion, okay? Don't cry. The girls and the boys don't cry, I tell you what I want you to do, don't cry. You will tell me how come Jill got so much? Because for this is trigo, this is EX. It will include the tangent normal, maxima, minima. You know what I mean? Connected rates of change. You know algebra we split it across a few chapters, right? But because they think that after the 15, 13 and 14 now, you are very clever already, you know. You understand? So they think you can do it, you know. You understand what I'm talking about? So I cannot just do the differentiation only. I must also put in maxima, minima, connected rate of change. You know, the testing of maximum, minimum point, stationary point. That's why it's so many. Do you understand what I'm talking about here? Wait, do you understand what I'm talking about here? Okay. So this is the trigo one, this is the EX one. Okay, don't worry. Okay, I a bit kind one. Okay, by Friday, right? 15.1 must be done, that's all. This one, no need. During March holiday, then do. Will that be okay? Can? Now, then I tell you what's going to happen. Hello. 不要讲话. On Friday, right? I will go through this one. No, I will not go through this one first. I will go through 15.3 first, the ln x first. So that the 15.3 I can also set, and if you cannot, you can still do it during the holidays. So you have 3 sets of differentiation to do during the holidays. Tak, and tak. Or do you want the next one as well? I must well give you the next one. But I haven't thought, no, you're okay with that, right? Okay, so you can compare how evil I am, right? Okay, let's take a look. Very evil, okay? But no choice, you know. You will see that actually my evil is actually kindness later, okay? Alright? Okay, so I'm telling you this, don't cry. Please don't cry, okay? Let me just say this again. I scared people, this is trigo, this is EX, understand? Then this one is the ln x one, understand? Why got so many questions? It's because must do tangent normal, must do maxima, minima, must do stationary points, must do connected rates of change, must do all the rubbish. Do you understand? Okay, so let me just say, on Friday, I must say it out loud. On Friday, I will teach this one. Okay? Then if got time, I will go through this one. Understand? But this set of work must do one. These 3 sets will be due only after the March holidays. Are you all clear with what I'm talking about? Yes or no? Fair enough, right? I have to finish now, no matter what, right? Correct now? Then you go and try lah. Everybody okay? Everybody clear with what I'm saying? Cannot. So, actually, from what I said, right, you can gather from it. Is this still even on Friday? Not really lah. Just bluff one. Can you see it's just a bluff thing? Do you understand what I'm talking about? But you don't use the time to learn HBI and just go to sleep, no. Understand or not? You must try some, you know, understand? Hey, auntie, uncle, understand what I'm talking about? Okay, very good. So these three sets actually due when in reality. After March holidays. Are you all happier now? Are you still very sad because there's a lot of work? There's actually a lot of work. Okay?